Hello everyone, this is Saurabh from Edureka. Today's session is all about computer vision using OpenCV in Python. For now, let us move forward and have a look at the agenda for today. So guys, this is what we'll be discussing today. We'll begin by understanding what exactly is the meaning of computer vision and how a computer reads an image. Then I'll tell you what is OpenCV and how it works. After that, we'll see how to create an image detector as well as a motion detector using OpenCV. So I hope you guys are clear with the agenda. Let us move forward and we will understand what exactly is the meaning of computer vision. So before I explain you anything, guys, I believe all of you are on Facebook, and the moment you upload any picture on Facebook, there's a feature called auto tag, right? So Facebook will give you suggestions to tag people who are there in the image. So how do you think that happens? That happens all because of computer vision. So computer vision is an interdisciplinary field that deals with how computers can be made to gain high level understanding from digital images or videos. So the idea is to automate tasks that the human visual systems can do. So a computer should be able to recognize that this is a face of a human being, this is what a lamppost looks like, this is basically a statue, so things like that. So let's move forward, guys, and we're going to see how a computer reads an image. Now this is very interesting. So notice the image that is there in front of your screen. So a normal human can easily tell that there is a New York skyline in this image. But can computers really see this? Well, the answer is no. Computers see a matrix of numbers between 0 to 25, 0 to 255. So for a colored image, there will be firstly three channels, red, green, and blue. And there will be a matrix associated with each of these channels. And each element of this matrix represents the intensity of brightness of that pixel. All of these channels will have their separate matrices, and these will be stacked onto each other to create a three-dimensional matrix. So a computer will interpret a colored image as a 3D matrix. So when I say that the size of an image is 700 cross 700 and it is a colored image, that means there are 700 rows, 700 columns, and there are three channels because it's a colored image. Similarly, if I say 300 cross 700, that means there are 300 rows and 700 columns, and if it's a colored image, there'll be three channels. Now, in the example which is there in front of your screen, we have an image which has a size of B cross A, and since it is a colored image, there'll be three channels. One thing to note here, guys, for a grayscale or a black and white image, there's only one channel. So if there's a black and white image and I say that the size of the image is 700 cross 700, it means there are 700 rows and 700 columns in one single channel. For a black and white image, there's only one channel. For a colored image, there are three channels, popularly called as RGB, and each element of the matrix represents the intensity of the brightness of the pixel. So this is how basically a computer reads an image. It will read an image in the form of matrix. It depends if it's a colored image, then it'll be a 3D matrix, and if it is a grayscale or a black and white image, then it'll be a 2D matrix. Similarly, if I want to calculate the number of pixels, all I have to do is multiply the number of rows, number of columns, and the number of channels. So if I say that the size of the image is 700 cross 700 cross 3 because it's a colored image, then you can go ahead and multiply these numbers and you'll find the number of total pixels. So let us move forward and we are going to focus on what exactly is OpenCV. Now, first of all, OpenCV is a library which is used for computer vision. It was first developed in the year 1999 at Intel by Gary Bradsky, and the first release came out in 2000. Let me tell you that OpenCV supports a wide variety of programming languages such as C++, Python, Java, etc., and also supports different platforms including Windows, Linux, etc., etc. Now, OpenCV Python is nothing but a Python wrapper for the original OpenCV C++ implementation. And in OpenCV, all the images are converted from or to NumPy arrays. So if there's any image, then OpenCV will first convert it into a NumPy array. And this makes it easier to integrate it with other libraries that uses NumPy, for example, SciPy and Matplotlib. Understand that all the images will be first converted to a NumPy array. So that's how OpenCV works. Since we saw that computer will first convert the image to a matrix, in this case, it will convert it into a NumPy matrix or a NumPy array, you can say. Now we'll directly jump into certain basics of OpenCV. So what I'll first teach you is how you can read an image, how you can perform basic operations, for example, resizing the image or displaying the image and things like that. So that's what I'm going to first focus on. So for that, what I'll do is I'll open my PyCharm and I'll execute the code there. But let me just first explain you what I'm going to show you. So first of all, I'm going to teach you how we can read a particular image. The first thing you need to do is obviously import the OpenCV module. Then we are going to read the image with the help of this imread function. So this one represents that it'll be a colored image if it is a colored image, and if we put 0 here, then it'll convert it into a black and white or a grayscale image, right? And let me tell you that OpenCV will read it as a NumPy array. So basically Python stores the images as NumPy arrays or matrix of numbers. So if it's a colored image, it will be a 3D matrix, and if it's a grayscale image, it will be a 2D matrix. So what I'll do, I'll just quickly open my PyCharm and I'll show you certain basic operations there itself. So guys, this is my PyCharm. So what I've done here is I've imported the CV2 module. And what I'm doing here is I'm using this imread function and I've given the path to the image. So you can see the name of my image is frank.jpg, which is present in this particular path. And one basically tells it to keep it as a colored image itself. So since I was telling you that all the images are converted to NumPy array, so it is a colored image, it will convert it into a 3D matrix. Let us see if that happens or not. So I'm just going to print this and let me go ahead and execute it. And you will obviously see a 3D array here. Similarly, if I go ahead and convert this to a grayscale image, if just all I have to do is put 0 here and we have a grayscale image here. So let me just go ahead and run this and you will notice a 2D array. Notice the difference, guys. And if you want to see what kind of a matrix this is, all you have to do is type in here type and it will show you the type, which is a NumPy n-dimensional array. All right. So I've told you earlier as well that OpenCV will convert all the images to a NumPy array. Now, what if I want to know the size of my image? For that, all I have to do is use the shape function and you will know the size of the image. Since it's a NumPy array, all I have to do is img dot shape and let us see what is the shape of our image. So it is 600 cross 800 because we have converted this colored image to a grayscale image. That means we have 600 rows, 800 columns and one single channel because it's a black and white image. Now, if I convert this to a colored image, you will notice the difference in the shape and you can see that 3 is added here, which basically means there are 3 channels RGB. So there are 600 rows, 800 columns and there are 3 channels. So we saw how to read an image. We saw how to print an image, how to print an n-dimensional array. Then we also saw how to print the shape of the image and what will happen if we convert it into a colored image. Then we saw that 3 was added in the end, which basically means 3 channels. Now, what we are going to do is we are going to display the image. How we are going to do that? We are going to use this wait key function in which if we don't specify any parameter and we keep it as 0, it means that the moment user presses a key, the window will be closed. And if we specify a time frame, for example, 2000 milliseconds, then the window will wait for 2000 milliseconds and then it will be destroyed. So this destroy all windows basically closes the windows based on my wait for key parameter. So if it is 0, the moment any person presses any key, then all the windows will be destroyed. And if I've given certain parameters like 2000 milliseconds, then it will wait for 2000 milliseconds and it will automatically close the window. Let me just go ahead and open my PyCharm and I will show you there as well. So guys, this is the PyCharm. All I will do here is I basically want to print it or I want to display my image. So I'll use this imshow function to give a name to this image. So let it be a legend. And we are going to type in here the name of the image here. This is my file name and this is the image name, right? So I have given the path here if you can see. Now what I'm going to do is I'm going to add the wait for key parameter. So for that, all I have to type here is cv2 dot wait key. And for now, I'll just keep it 0, which means that the user has to press any key to close the window. Now, what I'm going to do is destroy all windows function and let us go ahead and execute this and we will see the image. And the moment I press any key, it is gone. Similarly, if I type in here 2000 milliseconds, so it'll appear for 2000 milliseconds and it'll automatically go away. So now we saw how to basically read an image, how to perform basic operations, how to show the image, how to close the windows and things like that. Now I'm going to tell you how we can resize a particular image. So let me just go back and what I'll do is I'm going to resize this image. I'll go back to my PyCharm again and let me just create one more variable. Let it be resized, which is equal to cv2 dot resize, the name of my image and the shape that I want. So probably I want 600 cross 600, right? Let me just go ahead and run this. I want 600 cross 600. So instead of img, I'll type in here resized and let us see what happens once I do this. So you see that I have a resized image here. Now, obviously that is not symmetrical. So what can I do to make it symmetrical? I can just go ahead and divide it by 2 or 3 the way I want to reduce the size. So for now, I'm just going to divide it by 2 and let us see what happens. So basically, if you see the code here as well, what I'm doing here, I'm reducing it by 2, right? So image shape divide by 2 and I'm converting it into an integer. because even if it turns out to be a float value, I will convert it into an integer. So new image shape is equals to old image shape by 2. That's what I'm doing basically. So again, I'm going to use the resize function. For that, I'll open my PyCharm. So all I have to do here is type in here int to convert it into an integer. img.shape function I'm going to use 1 divided by 2. And I'm going to close the parenthesis. Similarly here as well, int, open the parenthesis, img.shape 0 divided by 2 and close the parenthesis. And I think we are good to go. So the size of the new image will become half of the old image. Let us go ahead and run this. So yes, we can see that we have reduced the size. Let me just keep it as 0 so that if I press any key, then only the window will be closed. Now, similarly, I can increase the size as well. So let me just go ahead and multiply it by 2 and increase the size. So my new image will be twice the size of the old image. Let us see if that happens or not. We'll run this and yep, it's a pretty huge image. Let me just close it for now. Alrighty then. Fine. So we have learned how to basically resize an image. Let me go back to my slides and we are going to focus on what we are going to discuss next. So we saw how to resize the image. Next up, we are going to see how we can detect a face in a particular image. So it's pretty easy, guys. What you need is an image, obviously. You need to create a cascade classifier and it will contain the features of the face so that your code can determine, okay, where is the face? Then what we'll use OpenCV that will read the image and the feature file and it will convert the image into NumPy arrays. So it will search for the row and column values of the face. So NumPy n dimensional array, the face coordinates, and it will display the image with the rectangular face box. So what we are basically doing here is we are going to first read this cascade classifier. We'll give the paths to it. Then what we are doing is we are reading the image that we are talking about. We'll give the paths to it as well. We are converting it into a grayscale image. cv2.color bg2 to gray is basically going to convert it into a black and white image or a grayscale image. Then what we are going to do is search for the coordinates of the image. So we have this gray image. We are going to search for the coordinates with the help of detect multiscale. This is basically to figure out where is the face. Let me just drill it down a bit. So this will create a cascade classifier object, right? And this is the path to the XML file which contains the face features. Then we are converting the colored image to the grayscale image. After that, what we are doing, we are using a method to search for the face rectangle coordinates. So this detect multiscale is basically a method which will help us to search for the face rectangle coordinates. And scale factor basically decreases the shape value by 5% and until the face is found. So smaller this value, the greater is accuracy. So scale factor is something I don't want you to focus too much right now. This decreases the shape value by 5% until the face is found. It keeps on decreasing it. The smaller this value, the greater is your accuracy. And after that, we are just printing the type and the face. And how we are going to add the rectangular face box. For that, we are going to use a for loop and a method to create the face rectangle. This is nothing but a method to create that rectangle. This is our image object, right? And this is nothing but the RGB value of the rectangle outlines. I've given it as some color. You can give it whatever color that you want. Now this is the width of the rectangular face box, and these are nothing but the coordinates x comma y. Then we have x plus width and y plus h. So this is nothing but x plus w plus comma y plus h. I've already written the code, so let me just take you through it. It's very easy, guys. I have a cascade a classifier object here that I've created, which will contain the face features. Then I'm reading the image which I want to create a rectangular face box around or detect the face. I'm converting it into a grayscale image. Then what I'm going to do is I'm going to determine the coordinates of the face. For that, I'm going to use this detect multiscale method. Then I'm going to add a rectangular face box around it. For that, I'm going to use this for loop. And this rectangle is nothing but a method to create that rectangular face box. After that, I'm resizing my image and that's all I'm doing. So what I can do is I can divide it by 2 so that it becomes easier for you to see. But I don't think so I need to resize this image. What I'll do is I'll just keep it the way it is and we're going to see that particular image itself. I don't think so I need to resize it. So I'll just type in here img and we have our code ready that will detect the face in the image. Yep, it successfully did that. So guys, this is nothing but the type. So we have a NumPy n-dimensional array. So this is nothing but the coordinates of the face. Now, if I go back to my slides, you can see here, these are nothing but the coordinates which I have displayed here. Now let me go back to my slides again and we are going to see how we can capture videos using OpenCV. Let's see how to use OpenCV to capture video with computer webcam. Now, before I move forward, guys, let me just tell you a few things. So what we'll be doing, we'll be using OpenCV for reading frames or images one by one. So what basically a video is nothing but multiple images or multiple frames which are displayed very quickly so that it looks like a video. So what we'll be doing, we'll be using loops to build a window where images will appear really fast so that you can see it as a video. Something like this guy. He's basically smoking a cigarette. It is nothing but two images, but since I'm doing it pretty fast, you can see it as a video, like he's smoking. Although I don't want you guys to smoke. Now, let us see how we can capture video using OpenCV. The first thing we need to do is import OpenCV, obviously. Then what we are going to do is create a video capture object. And this number basically tells the computer to use our built-in camera. If I want to use an external camera, for example, I have an external cam and I can put one to use that. Similarly, if I have two external cameras and I want to use the third cam, I can put two here. Apart from that, even if I have a video file, I can give the path to that video file as well. Then this will basically release the camera in some milliseconds. So let me just quickly execute this and you will see what happens there, right? I'll quickly open my PyCharm. Let me just go to the basics of py file and I'll just type in here video equal to cv2 dot video capture, and I'm typing in here 0 to use my built-in camera, and after that I'm going to release this, so I'm just going to type in here video dot release. That's all I have to do. Go ahead and execute this, run it again. Notice that the camera light will be on for split seconds. Again and again execute it. It'll be on for split seconds. So basically when you execute the code, you will notice that your cam light switches on for a split seconds and then it turns off. So what we need to do is we need to add a time delay, and for that what we need is a time module. So what I'm going to do is I'm just going to type in here time.sleep3, which will stop the script for 3 seconds. For 3 seconds, your camera will be on. So when you execute the code, the webcam will be on for 3 seconds. Let us see if that happens or not. I'm going to execute this now. So for that, I'll open my PyCharm again. So this is my PyCharm again, guys. I need to first add time module here. And now I'll add that time delay. Time.sleep for 3 seconds. Keep my webcam on. And here we go. So we have successfully added the time delay. It was that easy, guys. Now let's add a window that shows the video. Till now, we didn't see the video. We didn't see what's happening. So how can I add that window? So it's very, very easy, guys. This is basically a video capture object. Now this check is a bool data type that returns true if Python is able to read the video capture object. This is just basically a true and false kind of a variable that will return true if Python is able to read the video capture object. Otherwise, it will return false. Frame is a NumPy array. It represents the first image that video captures. Since we saw that video is nothing but multiple images which appears really fast and it looks like a video. So the first image or the first frame is basically what we will store in this particular frame, the NumPy array of that particular image. So it is a NumPy array. It represents the first image that video captures. We are going to print both check and frame, and we're going to add a time delay as well. So let us just quickly open the PyCharm and we're going to execute this code there. Let me just open it for now. What we are doing here is check comma frame equal to video dot read. Let me just print check, and I will also print frame, and let us go ahead and execute this. We'll see what happens. All right. So what happened here? Python was able to read the video capture object. That's why we have got the output as true. Basically, our check has returned true because Python was able to read that particular video capture object. Apart from that, this is nothing but the NumPy array for my frame, right? Which is pretty visible. I don't think so I need to explain you why it is a NumPy array, why it is three-dimensional. I think we have discussed quite a lot about NumPy arrays in the previous slide. So for now, what check and frame is, check is basically a bool data type. It will return true if Python is able to read the video capture object, and frame is nothing but the n-dimensional array. So guys, now we'll see how we can actually create a window. So what we need to do is we need to create a frame object which will read the images of the video capture object. And we will recessively show each frame of the video being captured. So all I'm doing here is using this imShow function again, and I'm going to give a name to it. And I'm going to show all the frames which are going to come till I close the window. So it's for 3 seconds. You're going to see a video being displayed on a window. And for that, I'm just quickly going to open my PyCharm. And I just need to add this imShow function there, and let us go ahead and do that. cv2.imShow. I'm gonna give a name, say let us call it as capture, I'm gonna type in here frame. Now we need to use this wait for key function. Wait key. Let us keep it as 0 so that whenever I press any button, it'll close the window. And finally, I'm gonna type in here CV2, destroy all windows. So now let us go ahead and execute it. So we'll see a window that will capture our first frame. And let us see if that happens or not. Here we go. So yes, the moment I press any key, the window will disappear. So this is how we can display the video on the window, right? Let me just go back. Now, how to capture the video instead of the first frame? Till now, what we did, we just captured the first frame that appeared in front of the camera. Because that is basically what? Video is basically what? It is nothing but multiple frames which appear really quickly and that comes out as a video. So what we need is now, we need to capture the entire video. So for that, what we'll do, we'll use a loop because I've told you earlier as well, that is what we're going to use. In order to capture the video, we will be using a while loop. And the condition will be such that unless check is true, Python will display the frame. Because what is check? Check will basically return true if Python is able to read the video capture object. And if it is not able to read it, then it becomes false. So our condition will be such that if check is equals to true, then Python will display the frames, right? It will display the frame on a window. So let me just take you through the code that I've written here. Video is equals to cv2.video capture equal to 0, which is basically a video capture object. I'm not going to repeat that. I have a variable a which is equal to 1. While true, while Python is able to read the video capture object, it'll enter the loop. A is equal to a plus 1, which will keep on increasing. Check comma frame. So it'll print the frame, basically the numpy array object. And what I'm doing here is converting the frame, the image, into a grayscale image. Then I'm going to show that grayscale image, and I've given it a time frame that is 1 millisecond. So it will be this will generate a new frame after every 1 millisecond. So this will basically generate a new frame after every 1 millisecond. It is nothing but a wait key, and after every millisecond the frame will change. And the moment I press Q, this break statement will come out of the loop and the window will close. Print A, this will print the number of frames that we have captured, and video.release, destroy all windows, right? So let me just take you through the code again. We are importing CV2 and time module. Then what we are doing, we are creating a video capture object. After that, we have a variable a equal to 1, which is nothing but it will tell us the number of frames that we have captured. While true, which means that while Python is able to read the video capture object, increase the a value by 1. Then these two statements, we are printing nothing but the frame, the n-dimensional array object. Then we are converting that frame to a grayscale image. Then we are showing it. And after that, we are generating a new frame after every 1 millisecond. That's what it is doing here. Then once we press Q, we are out of the loop and console will print the number of frames and all those things. So let me just quickly open my PyCharm and I will execute it there. So for that, let me just remove these things for now. So after this, I have a video capture object that you can see. Below this, I have a variable a equal to 1. Now I'm going to use while loop, while true, enter the loop, a equals a plus 1. Now over here, I'm just going to print the frame. And now I'm going to convert this to a grayscale image. Gray is equals to cv2 dot cvt color frame, comma. Now I'm going to type in here cv2 dot bgr underscore cv2 dot color underscore bgr to gray. All right. Next up, we are going to use this imShow function. Let me just show you what I'm going to do here. I'll just type in here cv2 dot imShow. Let it be capture again, and I'm going to show you the grayscale image. And then finally, I want a new frame after every 1 millisecond. For that, I'll type in here cv2 dot wait for wait key, and after every 1 millisecond. And over here, I'm just going to use a conditional statement which says that if key is equal to ord q, and then a colon, break the loop. And now I'm going to type in here print a, which is basically the number of frames. Now video dot release, and then finally cv2 dot destroy all windows. Import couple of modules, cv2 and time. Then we are creating a video capture object. We are defining a variable a equals to 1, and while the condition is true, That is, my Python is able to read the video capture object. We are going to create two variables, check and frame, where check is a bool type variable, frame is nothing but an n-dimensional array which will read the video. After that, we are printing it, printing the n-dimensional object, converting it into a grayscale image. We are showing it. We are also mentioning that after every 1 millisecond, the new frame should appear. And then once a user press Q, then the window will disappear and the control will come out of the loop. And then we are printing this number of frames, video.release. We know what is destroy all windows. So let us see what will happen once we execute this. And here we go. Oops, so there is an error. So all I have to do is define this variable key, and here we go. So let me go ahead and execute this. So yep, you can see the frame that is behind me, and you can see my hand as well. So let me just quickly press Q, and you'll see that window will disappear. And now we're going to talk about a motion detector. So this is our use case, guys. So let me just take you through the problem statement, why we are executing this use case, right? Everything exists for a reason. So let us understand what are the problems that this motion detector will help us to solve. So you have been approached by an organization that is studying human behavior. Now your task is to give them a camera that can detect any motion in front of it. And it should return a graph which should contain for how long the object or the human was in front of the camera. So this is how the graph should look like. This should be the starting time, right? The moment object appeared in front of the camera, for how long it stayed in front of the camera, then it went off. Then again it appeared at this particular time, then again it went off. So this is how it should look. Time at which object appears in front of the camera and the time at which the object moves away from the camera. So how we are going to execute it? So this is the flow diagram for that, guys. And first of all, we need to save the initial frame. So what will happen, since I've told you earlier as well, video is nothing but fast moving images. All right. So what we'll do, the moment we switch on the camera, the first frame, the first image that will appear, we will save it. Then we'll convert that image to a Gaussian blur image. You don't need to worry about it. I'll explain you what is Gaussian blur image. Then we'll take the frames with the object and convert it into Gaussian blur image. So basically this is done to give us the accurate results, right? So Gaussian blur image is something like that. You don't have to go into too much detail here to execute it, but just understand it. Just to increase the efficiency, we are converting our images to Gaussian blur. So we are converting our first image also to Gaussian blur, and the subsequent frames as well that will appear will also be converted to Gaussian blur image. Then what we'll do, we'll calculate the difference between the first frame and the frames that will appear after the first frame. Since the first frame is stored already, we are going to subtract that with the frames that will appear after that. Then what we need is, now because of this, we'll know, okay, there's a change in the frame. The initial image looked like this, but now since there's some movement or some motion, we can see that there's a difference in the subsequent frames. So we know that there is some motion or there is some object, but that object might be too small that we don't want to capture that. For that, what we do, we define a threshold that will remove the shadows and then too small objects or other noises. So basically we will define a threshold or the size of the pixel that should appear as and it will be considered as an object, right? I don't want a flying housefly to be considered as an object there. Just an example. Now define the borders of the object. So we need to give a border or a box there, right? And basically a rectangular box around the object. And then we are going to calculate the time when object appears and exits the frame. Now the question is how I'm going to execute it. So guys, this is pretty much from what we did last time as well. So what we have here is we are going to create a video capture object. Then we are converting the frame color to grayscale. Then we are converting the grayscale image to Gaussian blur image. And this if statement will basically store my first frame or my first image. The moment I switch on the camera, whatever image comes first, it will be stored in this particular first frame variable. So the statement says that if first frame is none, when there is nothing in the first frame, it will enter the loop. The first image that will appear will be stored in the first frame. And after that, continue means it will come out of the loop. Let's see what we are going to do next. After that, what we are going to do is we are going to calculate the difference. Since I've told you earlier as well, we are going to calculate the difference between a first frame and the subsequent frames which I have stored in gray. So this will calculate the difference. After that, I have defined a threshold. Now it provides a threshold value such that it will convert the difference value with less than 30 to black. If the difference is greater than 30, it will convert those pixels to white. So basically whatever object is there in front of the screen, it will convert that to white, right? Whatever the difference is. So that's why I've given the color as well. And this is basically the difference value that I've defined a threshold here. Similarly, I've defined one more threshold. You can see it over here as well, thresh delta that I'm using here. After that, what I'm doing is I'm defining the contours, or you can say the borders. So basically the borders around that object which appears. Now I'm adding one more threshold, guys. This will remove noises and shadows, or even a housefly, which I don't want to detect. So basically it will keep only that part white, which has area greater than 1000 pixels. So if my object has area smaller than 1000 pixels, it won't be detected because I don't want to detect it, right? So you can change it the way you want. You can keep it 5000, you can keep it 10,000, you can keep it 200. That totally depends on you. And this is basically to create a rectangular box around the object in the frame. And you know what it is. Basically, frame will change after every 1 millisecond. This will basically close the window and this will close all the windows. Now what we need to do is we need to calculate the time for which the object was in front of the camera. For that, we will create a pandas data frame. The pandas.data frame is what we are going to use here. That will have two columns, start and end, basically when object appears in front of the camera and when it went off. And we are going to tweak a couple of things. We are going to define this variable called status. Status at the beginning of the recording is 0, and as the object is not visible. So if there is no movement, then it will be 0 because there is no object that is there in front of the screen. But it will change the status when the object is being detected. The status will become 1. Similarly, we were going to append the status, list of status for every frame. For every frame, we are going to append it. So this basically tells us the second last status list value. All right. These two conditional statement will basically record date time in a list when change occurs. Let me tell you how. So if my status underscore list, the last value of this list is actually equal to 1, which means there is an object. But my second last value says that there was no object before in the previous frame. That means there is an object which has appeared, right? So that basically the time at which the object has appeared will be stored here. Again, which will be stored here. After that, if you notice the second conditional statement, which says that my last frame does not have anything. I mean, there's no object in front of it, in front of the camera, but in my second last frame, there was an object. That means the object went off, right? So it will note that time as well when the object was not there in front of the screen. That simple, guys. So this will basically create a pandas data frame that will have two columns, start and end, which will tell us when the object appeared in front of the camera and when the object went off from the camera. So this is how it is. And then what we are going to do is we are going to use this for loop in which we are storing the time values in a data frame. And then we are going to store it in a times.csv file. So it will be a CSV file. So time I, end time is equals to I plus 1. Ignore index. So basically, we don't have any index values here, right? We don't want to display the index. So there is no index value here. This for loop is pretty self-explanatory. So let me just go ahead and execute this first, and then I'll tell you how we have visualized. So here is our motion detector, guys. I've explained to you the code in detail. So what I'll do is I'll first, won't come in front of the camera. I'll go away because it has to first capture the first frame. Then only it can identify the difference between the subsequent frames. So guys, I'll execute it now. And what will happen? It'll first capture the first image which is there in front of the camera, and any movement that will happen, it will capture that. So the first frame will be stored. Then the difference between the first frame and the subsequent frame will be calculated in order to determine if there is a object in front of the camera or not. Let me go ahead and execute this. So guys, you see a plain background, there's nothing, right? So this will be saved, the first frame. And then let us see what will happen if I bring in my hand. So there's a rectangular box around my hand, you can see. So it is basically capturing the motion around the camera. And all of these things are saved in my pandas data frame. So you can notice my hand is coming in and then it is going off. So all of the time at which the hand appears in front of the camera and the time at which it went off will be stored in my pandas data frame because I have two columns, start and end. So if I just minimize this, let me show you the Gaussian blur image as well, right? So yeah, in that Gaussian blur image, I have defined that, to keep the object white if it is greater than 1000 pixels, right? So this is what comes up. Yes, this is Gaussian blur image. This is Gaussian blur. Yeah. And this is a gray frame, which you can see over here. Let me press Q. It'll close all the windows. Now let me show you this times.csv file. So, yep, this is how it looks. Now let me go back to my slides again. Now basically what we are doing is we are going to plot it on the browser using the bouquet library. Now guys, to explain bouquet, it'll take a lot of time, right? I've just written the code here to show you how the graph will look like. So this is my code that will help us to visualize the graph. So it is basically using the motion detector, which I have here, right? From this file, it will take DF, the data frame which we have created. So let me just go ahead and run this. So again, I'm just gonna put my hand a couple of times and gonna put my other hand as well. Yes. So yes, I think it's a good enough size of the data frame and it should appear in the browser. The moment I press Q, you'll see that there'll be a graph that will appear on our screen. And here we go, guys. So this is the graph that I was talking about. End time, start time. So let me just increase the size for you guys. So yeah, this is how the graph will look like. Start time, end time. So we have everything here. So I hope you have understood this and it was an interesting session for you. So guys, that's it for today's session. I hope you have enjoyed it. Thank you and have a great day.